Hi everybody. Today you can see the title up on the top of the screen. We're going to go through solving rational inequalities. And so what we're going to work on then is a little bit of review that we have on this front screen, this first page. What I'd like you to do is to go through and solve A and B. Okay, I'd like you to try to solve both as best you can. And then when you do solve them, can you make sure that in your notes you keep maybe about 3 or 4 lines blank underneath your solution to each of these? We're going to come back and we're going to end up finishing off something a little extra with each problem. So I'd like you to work your way through. Try to see what your instinct takes you based on last year. Okay, pause it now. Okay, and we should be back. So, this was not a big topic in your grade 11 course. So if it didn't come back to you, I wouldn't be overly concerned. Like, this is a scenario where I'm hoping that we were okay to be able to work our way through A. So for us to solve that inequality, last year we learned we can basically treat that as if it was an equation. So I can treat that rather than seeing that inequality symbol, I could just treat it like it was an equal sign. And maybe we ended up going through and getting our x's on one side of that inequality sign and getting our constants on the other. And I would say that we are doing very well if we remembered one last feature. If we do go through and divide out that -9, then I'm hoping we remember that anytime we multiply or divide each side of our inequality, we have to change the sign of the inequality, and we should have got down to a greater than 1. Now, as I said, we're going to keep a couple extra lines in. I would not copy this down, so this is not going to go into that space. I just want to make sure that we're all good with why we have to change the sign of the inequality. Take a quick peek and notice that if I write down that statement, we should all agree that 3 is greater than 2. But if we tried to treat that inequality as if it was an equation, and we did the same operation to both sides, like multiply both sides by -1, or divide both sides by -1, that all of a sudden, that inequality isn't true. So when we're trying to solve inequalities, we just have to remember that we can't really do the same operation to both sides and have our equation stay balanced, our inequality stay balanced, because we don't start with the premise that both sides are equal. And so as soon as I multiply both sides by a -1, it's like I'm flipping the sides on my number line. And therefore, it's not in the same relationship. And so, as long as we remember that if I do multiply or divide by a -1, then as long as I change the sign of the inequality, we should all be good that now -3 is less than -2. Now, I would also guess that a lot of you just wouldn't have even done that on that inequality. That because you just went through, I would probably imagine that I would have had a lot of people that would just give me the green equation, the green solution. That perhaps you are a positive coefficient person. And so you make a conscious effort of trying to isolate your variable on a side where your coefficient on your x is positive. In that instance, you then avoid having to switch the sign of the inequality. Now, some people are going to look at what I just wrote on the screen, and they're going to think that I switched the sign of the inequality, but just notice that I didn't. We always read our variable out. So, if I kept my variable on the right side, then x is greater than 1. We always read variable out. So, if we get that instance, I think we should be good. I'm going to leave that red solution. That just reminds us about that multiplying or dividing by a negative concept. Okay, I want us to be able to work through B. Maybe we got stumped a little bit on A. Now we have a little bit of a reminder. Maybe we can go through and solve B on our own. So I want you to pause the video now and give it a shot. Okay, we're back. So even if we took that extra shot, everybody should be working through then. That since we have some fractions, we may want to multiply out to eliminate those fractions. So in this case, I can multiply everything by 12. When I do multiply everything by 12, I can get rid of my division here. And therefore, 12 divided by 4 is 3. I can get rid of that division there. And so, if I expand everything, I'm going to have my 3 times an x plus 1. But we could probably even skip that line. That we can see it up in our original expression, I'm going to have to expand that 3 in and expand that 4 in. So my first line may look like 3x plus 3. There's nothing to divide out in the second term, so I can simplify. Expand in your 4. Expand in your 12. Simplify it. Maybe we spend a line simplifying each side. But pretty quickly we should come in on a 19x. Oops. I changed my inequality symbol to an equal sign. Yikes. That doesn't say equals. That says, if I'm reading left to right, greater than or equal. So greater than or equal my 17. And so x is greater than or equal to 17/19. Nice. Okay. Hopefully we matched up algebraically. I'm just going to shrink that down a little bit because I want to add another instruction into our problem. So I'm going to sneak back up and I'm going to add in the instruction and graph. And I'd like to just walk through a quick reminder of how we graph the solution to these inequalities. Before we start busting out a x and y axis, that's not how we graph these solutions. What we're going to do is just give a picture that represents the solution set for each one of these inequalities. So I don't think that this will necessarily come back to you, but we should be pretty quick to say that what I'm going to do is put down a number line, and in the middle of that number line, I'm going to put my key value down. It's 1. There was my solution to A. X was greater than 1, so I'm going to put down that key value of 1. And now I need to highlight which is my accepted values. So what are the x values that are the solution to that inequality? I need x is greater than 1, so I'm going to put a little open circle, and then I show the greater than side. Now, what we also do on our grid is we also put down the integer that falls on both sides of my key value. And so you can now see that the green is my solution on my number line. I keep that open circle because it doesn't include 1. It's just greater than 1. So everything up to 1, but not including 1. There we go. So to put down a quick picture of what our solution, our graph would look like, to B, I put on my key value, 17/19, and I put my integer on both sides. Well, my integer that would be greater would be 1, and my integer that would be less would be 0. Don't put down 18/19 and 16/19. Those are not integers. Now I need to put on greater than or equal to. Well, since I can include it now, I have a closed circle and my greater than. So that was all a review from grade 11, but as I said, I wouldn't be concerned at all if we forgot how to solve our inequalities. We should be fine now, and we should go, oh, okay, I remember that from last year. And so where we're going to go now is we're going to kind of jump in and we're going to deal with the whole rational aspect. So we're going to focus in not just on inequalities, but we want to focus in on the rational aspect. So I wouldn't even worry so much if the rational part doesn't jump back to you either. What I want to focus in on is a new direction that we're going to go. It's going to require what we just dealt with on the screen, but we're going to extend it a little bit. Today may get a little confusing for some people. And what I want to argue to you is just fight through it today. So what I mean by that is don't worry so much if you don't have the idea nailed down right away. So for those people who like to rewind, watch again, ask a million questions, I want to make sure that I have everything completely. I'm going to ask you to kind of let that go a little bit today. And don't be so concerned if we're confused on some stuff as we progress. I think by the time we get down to the end of today's lesson, I think you'll get it. Even if there are some moments throughout where you are really confused. Okay, be patient with the stuff today. Okay, here we go. And so what you see on the screen now is where we want to go with some stuff. So what I want you to do is I want you to try to go through and solve those three inequalities. Okay, I want you to stumble your way through as confident as you are or lack of confidence that you have. Who cares? Who cares if you hit a snag partway through? I want you to try to come up with solutions to those three. Okay, pause it now. Okay, we're back. So, I just want to walk through maybe troubleshooting a little bit some of your strategies in the past and maybe some snags that we're facing when we try to employ those strategies. I think everybody should have been okay on question C to be able to work your way through and deal with our old methods. D should have caused this a significant snag. And so when we look at D, we should really struggle with that one. And I might argue that E, maybe we were able to look at that one and solve that through inspection. But I'm going to argue that those two starred ones should have caused us some problems. So I want to jump in and I want to actually solve some of those using some varying strategies. Okay, we see these three identities, and I think C should have been okay. That we could have looked at that and said, well, to get the x all by itself, I'm going to go through and I'm going to get rid of my divide by -5, and so I'm going to multiply it out. Maybe we took a look and we wrote that down, and maybe we went back and we did a little check. And we said, okay, x is less than 0. And so maybe we picked a value where x was less than 0. So I'm going to pick a value of -1. And I go back and I sub it back in to my original. I'm going to get now a -1 over -5. That's 1/5. And when I try to compare that, my 1/5 is not less than my 0. And so I know I goofed. And maybe then we find that mistake and we say, oh, but wait a second. We multiplied out by a negative value. And every time I multiply by a negative, I have to change the sign of my inequality. So x should have been greater than 0. And then we go through and we check, hey, x equals 1, sub it in, everything works, nice. Okay, so maybe we went through and we chose to multiply out that value, and we didn't make a mistake. We came in with the blue solution and we were good. I'm just going to get rid of that check then, because we may have just had the blue on our page. But now we go through and we try to solve D using the same method. Well, to get rid of my divide by x, I can multiply by x. 0 times x is 0. And now we have a major problem. And I'm going to bet that a lot of us hit a significant snag on that. That we see that 5 is less than 0, and we say that's never the case. And so maybe we start to go so is there no solution then? But clearly there's some values that we could sub in for x. That maybe then you take a look at E and you say, okay, I'm going to skip over D. And you start to work your way through E, and like we get into the same mode. Well, if I'm going to multiply out my x minus 1, then I get 3 is less than or equal to 0. So it had nothing to do with the greater than, less than or equal to. That inequality sign didn't matter. We ran into another problem again, and we got no solution again. Okay. Clearly our old strategy of treating it like an equation, and as long as I do the same thing to both sides, is causing us a problem. Now, where is the problem? It didn't cause us a problem in C, but it's causing us a problem in D and E. And this is where our title for today of rational comes back into play. Remember that what we talk about when we say a rational expression is when we have a fraction that has a variable on the denominator. Notice in C, I didn't have a variable on the denominator. So I was okay to multiply out. Notice if you take a look back on B, we had fractions, but my denominator was always a constant. And so when I multiplied out, we were good. But now you take a look at D and E, and we notice that on my denominator, I'm multiplying out by a variable. Or at the very least in E, an expression that includes a variable. Okay, so why does that cause the problem? Well, let's take a look back if I erase some of this stuff just to give us some room to work. I don't want us to focus in on E right now, and what I'd like us to do is focus in on D. That when we took the action to multiply out that x, notice because I'm multiplying by an expression that includes a variable by x, I don't know whether I'm multiplying out by a positive or a negative value. In fact, as my x changes, then the sign of the denominator is going to change as well. So because I'm multiplying out by a variable, I don't know what I'm multiplying by. What if my denominator was negative? Then would we be okay to, I'm multiplying by a negative, so I change the sign of the inequality. Would you agree that 5 is greater than 0? Yeah, well, at least we get a true statement. But it doesn't lend us to, well, yeah, but for what x values? Hopefully you can see that because we are multiplying by a variable, we don't really know what we're multiplying both sides by. And therefore, we can't use that as a strategy when we're trying to solve an inequality. Okay, so how do we now go through to try to solve that inequality? Well, I want us to maybe take a look and try to use inspection. Notice what we have here. We have a fraction is less than 0. And I think that we may know how to make a fraction less than 0. So if we go back to grade 7 and we talk about the introduction of integers, then you guys know how to make a fraction less than 0. Like my less than 0 really just means a negative value. So how do I make a fraction negative? Well, I have two options. That what I end up having is potentially a positive divided by a negative. That gives me a negative value. Or I could have a negative divided by a positive. That would give me a negative value. I know that within my fraction, as long as my top and my bottom are different signs, then I get a negative value. Now, within those two cases that I could have, I'm hoping we can see that this second case can't happen. Because look back at your fraction. Look at the top of your fraction. That top is 5. It cannot be negative. It's constant. It is always equal to 5. And so that case 2 is never an option. That really, it has to be the first case. So, since my top is positive, then my bottom must be negative. So, my solution to D then would have to be that x is negative. X is less than 0. And notice, if you went back and you subbed in any x value that is less than 0, your left side will be less than your right side. Okay, let's take a look at E then. We can use that same reasoning. Notice, my fraction has to be less than or equal to 0. Well, less than or equal to 0 means a negative number or 0. Well, the first thing that we should recognize is there is no way to make that fraction equal to 0. Because the only way that you can get it equal to 0 is if the top of the fraction equals 0, and that top will never equal 0. It's always 3. So the only thing that I'm looking for is how do I make that fraction less than 0? And I'm coming right in like the previous problem. It could be a positive over a negative, or it could be a negative over a positive. And very quickly we can see that we can rule out the second option because my top is 3. It is always positive. And so therefore, since the top is positive, my bottom must be negative, and therefore x minus 1 must be negative, so less than 0. And now you come in on an inequality like question A. It's even easier. Now you could solve that by stating x is less than 1, and we have now solved that inequality. So I want you to take a look at those 3 problems and just notice that our strategy had to change. That rather than us just simply doing the same operation to both sides, because our sides don't start being balanced, they start with one side being greater than the other side. We can't just always do the same operation. We notice we get into trouble when we try to multiply both sides by a variable expression. Okay, hopefully we can see how we got to those blue solutions. And I think that if we understand how we got to those blue solutions, then we're doing pretty well. Things are going to get a little uglier though. So I want to walk through a different looking problem. Okay, I'd like everybody to take a look at question F. And we're going to walk through F together because I don't think we're ready yet for F. So as we jump in to tackle F, I want you to notice the one big difference between F and your previous problems. Notice you have a variable on both the top and the bottom. Okay, so let's walk through how we could solve this. Well, I have a fraction that is greater than or equal to 0. So I start to think about, well, what types of values are greater than or equal to 0? And that means that I have positives. I also have that equal to 0, so that also means it could equal 0. Okay, so now I start to try to solve it. Okay. Well, how do I make a fraction positive? Well, I know that to make a fraction positive, my top and my bottom have to have the same sign. So, for instance, like my first case could be, what if I had a positive divided by a positive? That would work. But I could also have a negative divided by a negative. So what I really have then are 2 cases that could both be solutions to that inequality. Okay, I'm just going to write this down a little more formally. And I want to just get rid of all that red, just so we don't get confused as we look back at this later. That what we can examine then are our 2 cases. So, case 1, what if I'm dealing with a positive divided by a positive? So what I can do is I can do exactly what that says. Make my top positive and make my bottom positive. Well, if you notice, what you have in blue now is you have two very easy linear inequalities. Well, let's go through and solve both. So my x must be greater than negative 4, and, that word's very important, x is greater than 1. Okay, I think we can shorten up those two statements into one. And so what I want to do is, if we can see it, then I want you to try to combine those into one statement. What sort of x values satisfy both, where x is greater than negative 4 and x is greater than 1? I want you to try to write that statement down. Okay, if we're struggling to see how to combine that or write that a little more efficiently, then my guess to you would be, go ahead and graph it. And I think that when you graph it, it's going to jump out and be obvious to you. So let's produce our picture. So I have my number line. And what I'm going to do is I'm going to graph my solution to x is greater than negative 4 in green. I'm going to graph my solution to x is greater than 1 in purple. But I'm going to put them both on the same graph, on the same number line. Okay, in green then, negative 4 would be down here somewhere, relative 1. So if I was now to graph those, x is greater than negative 4 would be an open circle here and everywhere to the right. If I was to graph x is greater than 1, then that would be an open circle here and everywhere to the right. What that word "and" means is that I need both to be true. And so if I asked you, well, where on your graph do both of those lines exist, the green and the purple, I would hope that we could come in and say, well, it's wherever x is greater than 1. And if we got down to that, then I think we're doing great. If we can see that x is greater than negative 4 and x is greater than 1, the only x values that fit both of those statements are where x is greater than 1, then we are good. I think the graph helps us to see it, though. Okay, now, we're not done the problem yet, but I do want to come back and just highlight that we also haven't even taken into account yet the whole equals 0. So let's go back and let's fit that in then. We could also have that fraction equal 0. Okay, well, how do I make a fraction equal to 0? My top has to equal 0. Okay, I want you to take a look at that starred line that I just put in. Because that's where I can now say, well, if my top equals 0, I can add in the equals 0 option to my top. My top can be positive or equal to 0, and my inequality would be true. Well, then that means that this inequality would also have an equals to option, which really means then when I go through and I graph, I should have had a closed circle there. Okay, well, notice that doesn't make any change to my solution. So we're good. Nice. Okay, I'm just going to eliminate that little star because it wouldn't have to be part of our solution, and we should be good. Okay, well, we're still not done the problem, though, because if you remember, that just says a fraction is greater than 0. I had that whole other case. I got case 2, which is a negative divided by a negative. Okay, we're going to go through pretty quickly on this one. So that says that I could have a negative divided by a negative. So I'm going to make my top negative and make my bottom negative. Well, I could incorporate the 0 as well, that if my top equaled 0, then my statement still is true. Okay, I can solve each of those inequalities. And if I can't see the joint statement that I could make, then I'm going to produce my graph. I'm going to do the same thing this time. My x is less than less than or equal to negative 4, is going to be graphed in green. My x is less than 1 is going to be graphed in purple. So now my joint statement would say, where do both of those exist? And we should see that x is less than or equal to negative 4 satisfies both of those inequalities. And there you go. I'm just going to box it in. You never have to. There's the solution to that inequality. Nice. We love it. Okay, I am hoping that as we walk through that case theory of how to solve our inequality, that it made sense to us, that we had an idea of the fact that a fraction ended up being positive, so we tried to think about how we could make that fraction positive, and we created these smaller inequalities. You see those in blue. We were able to go through and maybe simplify some stuff, that rather than having these 4 inequalities, we were able to narrow it down to 2. And we know that our solution then in that case is as long as x is greater than 1 or less than or equal to negative 4, that inequality would be true. Okay, I just need you guys to see that we never really want to solve an inequality this way. We need to understand the theory to it. And I can understand that some people are going to be a little confused through that theory. However, we don't want to do this. I'm going to change the question a little bit, and I'm just going to get rid of some of this little red that I wrote up here. Because I want you to see that as things get a little more difficult to us, just how crazy this case theory would be in terms of our means of solving. Like, what if that top wasn't linear? And instead of it just being x plus 4, it was now x plus 4 times x minus 3. What if the top was quadratic? Can you imagine what your case theory would look like? Okay, when is that fraction positive? Well, my case 1 would still be a positive over a positive. My case 2 would still be a negative over a negative. However, can we see that there's alternate ways to make your top positive? Like my top could be positive if my factors were a positive times a positive, then over a positive. Or it could have been like a negative times a negative over a positive. Those would all give me positive fractions. But then in the case 2, for me to have a negative, well, then it could be a positive times a negative over a positive. Or it could be a negative times a positive over a negative. Yikes. Could you imagine going through and dealing with that? Now you would have 4 separate cases that you would have to really examine. Let alone me giving you a quadratic on the bottom. You'd have to go through 8 cases. Because now my bottom could be a positive times a positive, or what about a negative times a negative, or then my positive, yikes. So there's got to be a better way for us to be able to solve this. And what I want to do is I want to walk through that better way. It's so important for us to understand the case theory, though, that really what we're doing is we're examining the sign of the top and the sign of the bottom at different x values. But let's present it in a more efficient way. So we're going to try question F again. So I just want you to notice this is the same question F. I'd like you to copy it down again, though, because now I want to walk through the means for us to be able to solve. Okay, the first thing that I hope we would notice is that we had key values, or key numbers. That when we take a look at the top of the fraction and the bottom of the fraction, we can determine key numbers, that is, the barrier between when that top is going to change from going from a positive to a negative, or vice versa. Well, let's take a look and see what makes the top 0. Okay, we should be okay that an x value of -4 makes the top equal to 0. Therefore, -4 is a key value. If I go to either side of -4, my top changes signs. Notice if my top was -5, if my x was -5, then my top is negative. But if my x is -3, then my top switches to positive. So -4 becomes an important value where we switch on the top. Notice on the bottom, what makes my bottom equal to 0? 1. And if I go on either side of 1, then my denominator changes signs. So -4 and 1 are my key values. If those are the only values where my top and my bottom change from positive to negative or vice versa, then why don't I just test those values or on either side of those values? So what we're going to do is we're going to build an interval chart. And what I'm going to do is I'm going to take my number line. Now, if you have a separate color with you, it can be important to write this down, but this will not be part of your solution. That really what I'm going to do is I'm going to take this number line that has my key values, but what I'm going to do is I'm going to write down the intervals. That what I have here in this first interval, I'll put a question mark in there, is going to be the interval of -infinity up to -4. What I have in my next interval, where I'm going to put a star, is from -4 up until 1. And then in my last interval, where I put my alpha symbol, I have 1 and greater. That what I have in blue there is me taking my number line and just breaking it up into intervals. Okay, I'm going to get rid of that ugly number line now because we can see it in my blue intervals. So now what we can do is we can just take an x value that fits inside of each one of those intervals and we can just test it. So let's pick the easiest x values to choose. Okay, well, how about -5? That fits in that interval. Somewhere between -4 and 1, well, 0 would be the easiest number that I could think to work with that fits in that interval. Anytime I get a chance to work with 0, I'm going to. And 1 and greater, or to the right of 1, well, I think 2 would be the easiest one to work there. So I've now chosen some values that fit in those intervals. I'm just going to test it. So let's take a peek back then and imagine subbing in -5 for my x. Okay, you're never going to write this down, but this is what I'm doing. And I just want to see what sign is that fraction. Notice, I'm not going to calculate stuff because I don't really care about what the number is. I just care about the sign. So I'm going to get rid of that red. And I'm going to imagine subbing in -5 for my x. So I get -5 plus 4. That's a negative on top. I sub in -5 on the bottom, -5 minus 1, that's a negative on the bottom. And when I now calculate that, a negative divided by a negative, that gives me a positive. And my eyes go back to my inequality symbol. Was I looking for positives? Yep. So that interval worked. Nice. I just found an interval in my solution. Okay, now I'm going to jump into the second interval, and I'm going to do the same thing. I'm going to imagine subbing in 0 for my x's. Well, 0 plus 4 on top gives me a positive, and 0 minus 1 on the bottom gives me a negative. A positive divided by a negative gives me a negative value, and now my eyes follow that red arrow. Was I looking for negatives? Nope, I'm looking for positives. So that interval doesn't work. And now I'll do the same thing with my last interval. I'm imagining subbing in 2, or I am subbing in 2. 2 plus 4 gives me a positive. 2 minus 1 gives me a positive. A positive divided by a positive is a positive. I'm following the red arrow. Is that what I was looking for? Yep. And there's my solution. Well, the nice thing then is I already actually have my solutions written down. Because when I built my interval chart, I created my intervals. And those two intervals that I just highlighted, those are the ones with the check marks. Those are the ones that worked. So I can go through then and simply state my solution. Oops, not with a highlighter. That therefore, negative infinity to negative 4 and 1 and greater is my solution. Now, here's where I want us to kind of have something in mind as we go. You have an option every time you build an interval chart and you use it to solve an inequality. That you can put a little bit of work in early and it pays off in the end, or you can kind of skip over some stuff early, but you need that focus in the end. Here's one of those instances where when we built our intervals, we paid no attention to the fact that that inequality symbol was a greater than or equal to. So I paid no attention to that. So when I get down to my final statement, I need to have the discipline to look back at that and say, hey, is it allowed to equal 0? And if it is, then whatever key value made my top equal to 0, I have to remember, oh, then it means it can also equal 0. So I need to make sure that I have a square bracket to ensure that now I'm including negative 4 as an option. Notice that I don't need a square bracket, or I can't have a square bracket on the 1, because if the 1, or if x equaled 1, then my denominator would equal 0, and that gives me undefined. So you take a peek now, and you'll notice that that solution that we got to f is the same solution as what we did using our case theory. But I'm going to bet and say that that was an easier solution to work through. It also becomes a much easier solution for us to work through as that fraction gets uglier and uglier. Okay, here's your other option. I'm just going to get rid of those stars because for some of us, we're going to put a little bit of work in early so that we don't have to worry about it in the end. I want you to take a look up at your interval chart. And as I go through to complete that interval chart, maybe what I'm going to do is I'm going to put my work in then. So as I go to build that chart, and actually I'm just going to get rid of the whole thing here. Now is when I'm going to focus in on, can it equal 0? In this case, it can. So when I build my interval chart, negative 4 was the key value that made the top equal to 0. I can include that negative 4 then. 1, I can't, so I need to make sure I have round brackets so that I'm not including it. I chose to put my focus in about the equals to right at the beginning of my interval chart. So since I worked hard then, now I just get to copy the intervals that made that, inequality true. Now, okay, there is the method that I would like us to use to be able to solve rational inequalities. As I said earlier, I think today's going to be a confusing day. But I'm hoping that as we work through more and more examples, then we can start to see how this stuff all comes together. So let's jump into something that's a little uglier. Okay, you guys can take a look at question G, and you'll notice that something significant has happened. That I don't have a fraction greater than or less than or greater than or equal to, less than or equal to 0. Now it's greater than 2. I'm just going to argue to you that I don't think that that's a meaningful difference. It's important when we first recognize the problem, but in terms of strategy, I don't think so. That if we understood our case theory earlier on, then our whole motivation is, can we get that to be a single fraction greater than or less than 0 to be able to examine our cases? So I'm going to put in a bunch of algebra right now that maybe we can get everything to one side of the inequality. I have my greater than 0. Perfect, that's what I want. The problem is the left side isn't one fraction. It's 2 terms. So I'm going to make that one fraction. In this case, I have to get a common denominator. So I need to multiply my negative 2 by x plus 1. Well, now I can go through and I can expand my brackets because I'm going to have to simplify that fraction. And when I do simplify it, I get down to this. And I actually really like that now, because that line that I just starred, that's the equivalent of question F. I have a single fraction with my inequality symbol, and it's being compared to 0. Nice. Okay, where this one's going to be a little choppy as we go through. I want us to try our bits as we go through. So you now have that purple fraction, and what we're going to do is we're going to take it in its parts. The first part that I would like you to do is to write down what are the key numbers for that fraction. Okay, pause it now and jot those down. Okay, I'm hoping that we're back, and those key values for us were 1/2 and -1. Just be careful a little bit. If we made a silly little sign mistake, you can always take the top, set it equal to 0 to solve for your key value. Or take the bottom, set it equal to 0 to solve for your key value. So we have the means to do that. But you never have to show me that green. If you can see it, work it through, jot them down. Okay, now that we all have the same key values, now I want you to build your interval chart. So go ahead and build your interval chart. Pause it now. Okay, we're back. So hopefully we have an interval chart that looks something like this. I'm going from -infinity up to my first key value, -1. Then I'm going from -1 up to 1/2. Then I'm going from 1/2 forever to the right. There's my number line broken up. The nice thing is when I was looking back, at my inequality down here in purple, it was just a greater than symbol, so I didn't even have to worry about do I have square brackets or not. Okay, now that we have our interval chart, I want you to take the next step. I want you to go through and pick the easiest x value that you want to work with that fits in each one of those intervals. Go ahead, pause it now. Okay, we're back. So my guess is we probably picked a -2 in that interval. I have the chance to use 0, so I'm going to in there, and probably 1 for that interval. Hopefully we match up. Okay, now what we're going to do is we're going to figure out what sign would fit in that first interval. What sign is that fraction for that first interval? And we are all focused in on our purple inequality. So I want you to go through and try to come up with the first interval, subbing in your x value of -2. Pause it now. Okay, we're back. So as we focus in on that, I'm going to take a -2 times a -2, so that's a positive. Add on more, well, my top is positive. On the denominator, I have -2 plus 1. That's a negative value. A positive divided by a negative is a negative. And when I look at that circled inequality symbol, I am looking for positives, so that interval does not work. Okay, hopefully we match up. Now what I'd like you to do, finish off your interval check. So I want you to complete for the next two intervals. Okay, pause it now. Okay, we're back. So if I sub in 0, that becomes so nice because I get a I get a positive on top, sub in 0 on the bottom, positive. It's so easy to sub in 0. That gets me a positive. And when I look back at my red circled inequality symbol, I am looking for positives. Yikes, that one worked. Did the same thing in the last interval, subbed in a 1. Well, -2 times 1, -2, add on 1, that's a negative. On the bottom, 1 plus 1 is a positive. Negative divided by a positive is a negative, and that was not what I was looking for. And so in this instance, I only had one interval that worked. Write out your solution. So the interval that did work was the interval from -1 up to 1/2. And there's your solution. Now, as I've said earlier, I don't care what form you want to write that in. You can use set notation, interval notation. So if you wanted to, like you can say that x has to be greater than -1 and less than 1/2. I do not care what notation you use. Feel free to use either. Okay, nice. So I would call G an average, like on the easy side of average for us in terms of rational inequality. I want to jump into something that's going to be a little more usual for us. So let's take a look at H. So you have something a little uglier. I think we can start to work on this one on our own. So what I'd like you to do is to try to do all the simplification you can. Get that down to one fraction, an inequality symbol, and 0. Okay, pause it now. Okay, we're back. So, a couple things that I think we should be okay with. We should be good with being able to picture this line. That we are going to maybe bring the 3 over x minus 2 over to the same side. We should be okay to picture our common denominator going to be x plus 5 times x minus 2. I think that we should be able to be comfortable jumping straight to that. That if we can see bringing that fraction over, then our denominator will be a common denominator. We should be able to picture that I'm going to have to multiply my 2 times an x minus 2. And since that 3 was positive on the right, it's going to be a negative value. I have to subtract it on the left. And at the same time, get my common denominator. That maybe we can come in on that blue line as your first line. You take a look and see what I just did compared to what you went through. If you're not comfortable jumping those many steps, then don't. Put in something in between and we're good. But I need you to know that I'm okay with you getting to there. Okay, now we can collect like terms on top. Maybe we put in a line where we start to expand in the 2 and expand in the -3. But for everything I just said, like, we could be okay to expand in and get our x's. So we have a 2x minus 3x. That's a negative x. And then we have a negative 4 minus 15 is a negative 19. And we can come right in on that line. And that's all that we would have to do in order to simplify. Okay, we now have a fully simplified fraction. We have our inequality, and we're comparing it to 0. So our job now is to come up with our key values, create your interval check, test your intervals, come up with your final statement. Okay? You should be good to be able to finish off this problem. So let's pause it now. Okay, we're back. So hopefully we came up with some key numbers. Those key values for us, well, what makes the top equal to 0? That would be a negative 19. What makes my bottom equal to 0? A negative 5 and a positive 2. Now, I just want you to notice that this was one of those questions back when we tackled F that I kind of threw at you as a bit of like a scare tactic. But we don't want to use cases to be able to go through because look at all the possibilities. I just want you to notice that when you built your interval chart, it really didn't expand anything. Like worst case in this scenario is you had one extra interval to check. It didn't require multiple cases to go through. And this is why we like using an interval chart to be able to check our solution. So hopefully that's what we have. And if I was to guess, then we're probably going like negative 20 for that interval, maybe negative 6, 0, and 3. Okay, I'm going to go through and I'm going to imagine subbing those values in. So if I sub a negative 20, and again, we are coming in to our simplified fraction, then my top becomes positive, my bottom becomes a negative times a negative. Now, if you want to write this in, that that's equal to a positive over a positive, then feel free. But I think we should be at a comfort level where we can see that, and therefore the overall fraction would be positive. My eyes come right back to my inequality symbol. I am not looking for positives, I'm looking for less thans, for negatives, so that interval does not work. And I'm just going to alternate colors so we don't get lost in our interval check. If I sub in a negative 6 for my x, my top becomes negative. My bottom becomes a negative times a negative. Well, that's going to give me a negative over a positive, which is a negative. And I look back at my interval. That is what I was looking for. Okay, sub in my negative 5 to 2, so I'm subbing in a value of 0. My top is negative. My bottom is a positive times a negative. So that would be a negative over negative, which is a positive. And that is not what I'm looking for. Sub in my 3, that's a negative on top, times a positive, or divided by a positive times a positive. That is a negative over a positive, which is a negative, and that is what I'm looking for. Okay, hopefully you noticed I put no consideration whatsoever into was there an equals to in my inequality. So now I have to put that consideration in. And so when I go through to state my final solution, my eyes are also going back to which key value made my top equal to 0. It was the negative 19. So any interval that works, this first one, I can have my x value equal negative 19. It can't equal anything else because then those others would cause the fraction to be undefined. And there we go. So hopefully we can see that as your expressions or inequalities start to get a little more complex, like a little uglier, then the most it requires is like more work, not more difficult work. Okay, we got one more. I want to leave you with question I. I think you should be good to go start to finish. I think if you're able to go through and you're able to solve I, then I don't think there's going to be anything in your practice that's going to cause you problems. So let's go start to finish on this one, and we'll see if we match up in the end. Okay, pause it now. Okay, we're back. So if at any point you notice you made a mistake throughout this process, then the second we correct it, I want you to pause the video again and try to finish it off on your own again. We want to be as active as we can be, and we also want to be as independent as we can be. So let's see if we match up. I need to get this fraction over to that side and try to simplify it. So my common denominator is going to be that. That means I'm going to have to multiply that x by an x plus 2, and I'm going to have to multiply that negative 3 by a 2x minus 1. Okay, now I can go through and expand my brackets. On top, I'm going to get an x squared plus 2x minus 6x plus 3, all over a 2x minus 1 and an x plus 2. Notice I kind of put the blinders on. I shouldn't say the blinders. I just kind of mechanically was trucking through this one a little bit. And now as I go to try to get my key numbers, I notice my top is still quadratic. So for me to solve my top equal to 0, I can factor that top. And finally, when I get down to that scenario, I can now state my key numbers. What makes my top equal to 0? 3 and 1. What makes my bottom equal to 0? 1/2 and negative 2. Some people even like, right now, looking back and seeing the equals to, and just identifying that that 3 and the 1, I can equal that value. Okay, I just want to draw your attention back to here for a moment, because look how nice I was to you. That top trinomial, it factored. Hey, what do you think you'd have to use if it didn't factor? Quadratic formula, nice. See the way we're tying all this stuff together? It's great. Okay, so if we needed to make any corrections, we're going to pause it and we're going to make them. Otherwise, we're going to go through and build our intervals. So forever left up to my first value, negative 2. Negative 2 to my next value, 1/2. 1/2 to my next value, 1. 1 to my next value, 3 and greater. There are all the intervals that I need to check. So I got to check 5 intervals with those key values. Okay, I'm going to pick my values. So maybe a negative 3, 0, I don't know, like 0.9 would fit in that interval, 2, and 4. I just want to draw your attention. I'm going to bet and say that you probably have 0.75 down or 3/4 down for that middle interval. It doesn't matter. Pick any value that you find easy to sub in. Okay, we're going to check that first interval. I'm subbing in negative 3. So I sub in negative 3, and I'm going back into my factored form. So that's going to give me a negative times a negative all over a negative times a negative. That whole thing's going to give me a positive. Was that what I was looking for? Yep, it works. Sub in your 0, then that's a negative times a negative over a negative times a positive. That gives me a negative. That does not work. Just again, make sure that we are all looking at the inequality of our final form. Okay, I think all these positives, negatives are going to start to blend in a little bit. I'm just going to change colors, alternate from here on out. If I sub in my 0.9, well, 0.9 minus 3 is a negative. 0.9 minus 1 is a negative. On the bottom, 2 times 0.9, that's bigger than 1. So when I subtract 1 from it, I get a positive. And 0.9 plus something is going to give me a positive. That's a positive. That's what I was looking for. Sub in your 2. That's a negative. That's a positive. 4 minus 1 is a positive and a positive. That's a negative. Nope. Sub in your 4. Positive and positive. Positive and positive. Beautiful. So in this case, I have 3 intervals that work. I have 2 values I have to be conscious of that make my top positive, 0, and therefore my first interval that works is negative infinity up to negative 2, but not including it. My next interval that worked is going to be my 1/2 up to 1, but I can include 1. And my last interval is going to be 3, of which I can include, and up to infinity. I can never equal infinity, so I have my round bracket. There you go. And I'm going to argue to you that other than having quadratic formula in there, then that's going to be about as ugly as you can face. Okay, we had a big day today. This was a big topic. Your job is obviously to jump in and get as much practice as you can to feel comfortable with that concept. If you have any questions, make sure you reach out, message me. Take your time. There might be some moments where you go back and you watch certain portions, like maybe going back to those first 3 problems now and trying those using an interval chart. You might be able to see the way you can apply it to some relatively simple inequalities. Okay, good job today. Best of luck with your practice.